In this video, I'm going to get to the successful conclusion of cutting rope with a hot wire, homemade, and also explain PWM. Depending on the editing, you will have seen this little device being used to regulate the current or power going through a wire to cut some rope. The way it does it is by pulse width modulation, and I'm going to show you what it is using the oscilloscope in the background here. So this time, instead of heating up a wire, I've got it running a light bulb, and I've got it hooked up to the oscilloscope and an ammeter. So we can see the current here, we can see the voltage here, and we can see the pulse width modulation when I turn this on. So here we go. I'll turn it on and see on the screen there, we've got a thing getting wider and there's a light bulb getting brighter, and you can see that cyan line getting longer and shorter and then going down to just a point and then off. So that is how many volts are going out to the light and how far the gap is between these two is the actual volts. So that's 12 volts between there and there. But this is also a time, and if I open this up a little bit, that gap there at the moment, that is 20 microseconds, I believe. Let me just super double check. Yes. So 20 microseconds. Now this means that it's only switching the power on to this light for 20 microseconds, and then it's off for an amount of time, and then it's on again. Now when we turn it right down, we see that point, and using my pre-prepared notes, that spacing between those is 90 microseconds. So with pulse width modulation, every 90 microseconds it switches the power on. And depending on so that's the pulse, chink, chink, chink. And depending on where I've got the dial turned is how wide that pulse is. So there it's just a little spike, and then I turn it up a bit and it gets wider. So that means the power is on for longer. And what this light bulb sees essentially, because this is so fast, 90 microseconds between here and here. So that's divide a second into a million, and that's 90 of them from there to there. So this is happening really fast. Another way of saying 90 microseconds, turn the brightness down, is 11 kilohertz. So that's a reasonably high pitch frequency. You might actually hear it coming out of here. So to all intents and purposes, if I set this to roughly 50, so there, so it's roughly half off, half on, that is seeing, the light bulb is basically seeing 6 volts. So it's like a 6 volt power supply now. And this is just really nice. So you can go from no volts to 12 volts with the turn of a dial. And there you go. That's what pulse width modulation is. So there's two terms in pulse width modulation. There is the frequency, which here is 11 kilohertz, also known as how often it happens, so 90 microseconds. So that's the frequency of the pulse. And then there is the width of the pulse, which is also called the duty cycle. So there I'm on about 50%, so that's a 50% duty cycle. Up here, 90%, 100. So there you go. Now you more or less understand pulse width modulation. Well, you understand it as good as I do, and I think I understand it well enough to be dangerous. So you can be too. Alrighty, I hope you enjoyed this illuminating lesson from the lab, and have a good day. Ooh. So we have it cutting now. Here is some actual rope being actually cut. We have smell mitigation and drawing about 8.5 amps now. with how many volts? Where is the zappers? There is the zappers. On the outside. On this way round. There and there. Which is 2.7. So 2.7 volts. Now 8.5 amps. Do your own maths because I do it in my head. But it seems to be doing the job because we're ripping through it. Well, I hope you like that. And for my last little trick, to just show you one more thing, if I zoom in on this, we'll see that actually, while it might look like a square wave, it's really hard to switch things off and on smoothly. So when you zoom right in, so now we're looking every single one of these little squares, so about the width of my finger is 50 nanoseconds. So tiny, tiny little bit of time. You can see that it's struggling to switch on and off cleanly. But anyhow, that's a topic for another video. I'll leave you with my ugly mug and say, I hope you found that informative. See you later.